This is question 3 of step 2, 2010. We are told that the formula Fn equals a lambda to the n plus b mu to the n holds, and we're given 4 initial values. F0 is 1, F1 is 1, F2 is 1, F3 is 2, and we are asked to use this information to establish the formula given lambda squared plus lambda mu plus mu squared equals 2. So we write out the equations this entitles us to write out. We have F0 equals a lambda to the naught plus b mu to the naught, which is naught, so that a plus b equals naught. We have F1, which is a lambda plus b mu equals 1. We have F2, which is a lambda squared plus b mu squared equals 1. And F3, which is a lambda cubed plus b mu cubed equals 2. And from this result here, it follows that b equals minus a, which enables us to rewrite the equations as I shall show. And here we have our new equations in the bottom left, which I shall label 1, 2, and 3. And if we look at the form of the statement we are being asked to prove, we should recognize that dividing 3 by 1 should get it for us. And so we have a lambda cubed minus mu cubed over a lambda minus mu. The a's cancel. And so we're doing lambda minus mu into lambda cubed plus 0 lambda squared mu plus 0 lambda mu squared minus mu cubed. And now using long division, lambda into lambda cubed is lambda squared times lambda squared cubed minus mu lambda squared minus mu lambda squared down. Lambda into mu lambda squared is mu lambda times lambda and now we minus, and we get minus for plus mu squared lambda minus mu cubed, and lambda into that gets us plus mu squared lambda minus mu cubed, and there is no remainder. And so F3 divided by F1 is lambda squared plus lambda mu plus mu squared, which is the same as 2 over 1, which equals 2. And now, using the results in front of us, we are going to discover the values of lambda and mu. Given that lambda squared plus lambda mu plus mu squared equals 2, what we need is to find an expression for lambda in terms of mu, and it should be reasonably obvious that dividing equation 2 by equation 1 will give us that relationship. And if we look at the division I have carried out there, the a's cancel. Difference of 2 squares, lambda minus mu times lambda plus mu, all over lambda minus mu, which is 1 over 1, because both those expressions equals 1. And so we now know that 1 equals lambda plus mu, and we can now substitute that into the equation we have to solve. And so I'm going to say that mu equals 1 minus lambda. So I have lambda squared plus lambda 1 minus lambda plus mu squared 1 minus lambda all squared equals 2. and that gets me a quadratic, which is lambda squared plus lambda minus lambda squared plus 1 minus 2 lambda plus lambda squared equals 2. And so we can see that they go. And we have lambda plus 1 minus 2 lambda plus lambda squared equals 2. And so we have lambda squared minus lambda minus 1 equals 0. And so we now use the quadratic formula on this. Lambda equals 1 plus or minus the square root of 1 minus 1 squared minus 4 times 1 times minus 1 all over 2. So that lambda equals 1 plus or minus the square root of 5 over 2. And mu will equal 2 over 2 minus 1 plus or minus root 5 over 2. And so mu will equal 1 minus or plus root 5 over 2. And so we can choose it this way. Lambda equals 1 plus root 5 over 2. And mu equals 1 minus root 5 over 2. And so if we put all this into the statement for F1, we're entitled to say that A times 1 plus root 5 over 2 minus 1 minus root 5 over 2 equals 1. So if I multiply both sides by 2, I obtain this result here. So that 2 root 5a equals 2. So that root 5a equals 1. And so a equals 1 upon root 5. And we now have a formula for the nth Fibonacci number, which is 1 upon root 5 times 1 plus root 5 over 2 to the power of n minus 1 minus root 5 over 2 to the power of n. We are now being asked to compute f6 using this formula. And f6 will be 1 upon root 5 times 1 plus root 5 to the power of 6 over 2 to the power of 6 minus 1 minus root 5 to the power of 6 over 2 to the power of 6, which will be 1 over root 5 times 2 to the power of 6 multiplied by 1 plus root 5 to the power of 6 minus 1 minus root 5 to the power of 6. And by the principle of the difference of two squares, I can split it up like that. 1 plus root 5 cubed minus 1 minus root 5 cubed multiplied by the two added together. And by doing a bit of multiplying, I can discover that 1 plus root 5 to the power of 3 equals 16 plus 8 root 5, so that 16 minus 8 root 5 must be 1 minus root 5 all to the power of 3. And this enables me to complete my work here. And so I have 1 plus root 5, I've got 16 plus 8 root 5 minus 16 minus 8 root 5 16 plus 8 root 5 plus 16 minus 8 root 5, and this gives me 16 root 5 there, and 32. I beg your pardon, I made a mistake. Hold on. And the first one here, that gives me 16 root 5 there, and then I multiply there by 32. And so F6 will be 1 over root 5 times 2 to the power of 6, which is 64, multiplied by 16 times 32 times root 5. And I can cancel that down there. So I've got the root 5's go, and I've got 16 times 32 over 2 times 32, and so the answer equals 8. And so this sum to infinity that's being asked for comes to the sum of 1 over 2 to the n plus 1 times the stuff in the brackets. And if I take the a outside and put 2 to the n inside, I get the sum to infinity of a over 2 lambda over 2 to the n minus mu over 2 to the n. And inside the brackets, what we have are two geometrical progressions. The first one, we're adding lambda upon 2 to itself all the time. So we've got n is 0 at first. We've got 1 plus lambda upon 2 plus lambda squared upon 2 squared, and so on. And we know that the modulus of lambda is less than 1. So using this formula here, we have 1 over 1 minus lambda upon 2, which is 2 over 2 minus lambda, is the sum of the first progression. And by analogy with that, with the one with mu, we have 2 over 2 minus mu, and we're subtracting the one from the other. And so keeping things in terms of lambda and mu, I arrive at this minus sum here, which I work out in terms of lambda and mu, and I obtain this result here. And if we look at the arithmetic, we find that lambda plus mu is 1, lambda minus mu is root 5, and lambda mu is minus 1. And so when we subtract the sum to infinity of the one GP from the other, we find that in the brackets we get 2 root 5. So to recap, that was the sum we had there, the sum to infinity of a over 2 with one geometric progression to the sum infinity subtracted from another. That became 2 root 5, and so that becomes a root 5. But we recall that a is 1 upon root 5, and so the answer equals 1.